Let's review these three types of problems in a contingency table. We're looking at the and, the or, and the given type of problems. And again, just as we learned earlier, there are two strategies that we've seen. We can use Venn diagrams to help organize our thoughts, or we can use the addition or multiplication rule. And sometimes one is easier than the other, depending on how it's given. So let's start off with A. So we have this situation where we have a magazine article reporting on Springfield Schools District's magnet programs and their impact of an applicant's ethnicity on the likelihood of admission. So here we have different ethnicities with Black / Hispanic, Asian, and white, and then whether they were accepted, waitlisted, or turned away. And there's totals that are given as well. So if we wanted to find the probability that a randomly chosen student is accepted and white, as we've seen, what does that and mean is they're in both groups. So we can almost imagine a Venn diagram here. If we were to say these are the accepted groups, and these are the students that are white, just like our Venn diagram, we see that we have two circles, and what is represented by the and is their intersection, where they overlap. So we see right here that 316, those are the students that are in both groups. Those are the students that are both accepted and white. So this would be just 316 out of the total of 750 students. And the Venn diagram method makes this very easy to see how many are in both groups. On the other hand, if we wanted to, we can use the multiplication rule because the and is multiplication. You'll see it just becomes more complicated. But if we wanted to use the multiplication rule, remember that means we're going to multiply the probability of the first one to get a piece of that. Then out of those students, multiply by the probability of the second one. So here we can see if we wanted to find the probability that a student is accepted, well, there were 920 students that are in this accepted circle. So it'll be 920 out of the 1750. And then out of those 920, we want to narrow it down even more. How many of them are going to be accepted? Well, we're only looking at these 920. And out of those 920, how many of them were also white is just, again, this overlap. The 316. So this would be times 316 out of those 920. And as we see, these 920s actually just cancel out, and we end up with the 316 out of 1750. So both methods work, the multiplication rule or just looking it up on the table. Let's take a look at the next one. Here we have an or statement. So going back to how these looked like with our Venn diagrams, the or is anyone that's in the Asian group or the accepted group, or they could be in both groups. Anyone in either one of those circles. So let's take a look at this. Again, the accepted are these students here. The Asians are these right here. And so we're looking at anyone in any one of these circles. So one way we could do this is we could just add the numbers together of all these students in any one of those circles. Because if you're in this circle that I just highlighted, then you are a part of this group of being either Asian or accepted, or possibly both. So I could have done something like 484 plus 120 plus 316 plus 40 plus 139. And there we go. Notice we didn't list 120 twice because we already counted them once. And this would be all out of, again, the 1750. And if we were to add that numerator together, we would get about 1099 out of the 1750. Now let's see how this would work out if we were to use the addition rule. So remember, what does the addition rule tell us is we can add the probability of the first thing plus the probability of the second thing, but then we're going to subtract out the overlap. So let's put this together. If they were Asian, well, we saw the probability of selecting an Asian student is 299 of them out of the 1750. Plus, we want the probability that they're accepted, so there's 920 of those out of the 1750. But again, if we add those two numbers, you're going to see we get something higher than 1,099. And why is that? It's because these 120 that's in both groups is added to this number and also to this number. So what do we need to do is we need to subtract it once, so that way it adds up. And if we go through that addition and subtraction, you'll see we get the same exact answer. 1,099 out of 1,750. So again, multiplication rule goes with the and. The addition rule goes with the or. So which one is faster? It's up to you, whichever one you choose. Let's take a look at the last question now. This is when something is given. So here it always helps to rewrite it in the probability notation. We want to still find out what's the probability of selecting a student who's black, but they're giving us some information. They're saying we already know that they are accepted. So it's only out of students who are accepted. So everyone else we could ignore, because only out of these accepted students is what we're looking at. So all of these people, we can ignore all those numbers because we're not looking at them. We're only looking out of the accepted. So again, the way I like to think about this is, since whatever comes after the given bar, we're going to put that in the denominator, since it's only out of those students. Well, how many students were accepted? We saw was 920. And then out of those accepted students, how many of them were black or Hispanic? I believe they should have said Hispanic also. Well, we see that there are 484. So one thing that often comes up is the question is, when do we know that we have to change this denominator to something other than the grand total of the 1750? It's basically whenever we know some other piece of information is given. When we know some piece of information is given, it changes who we're looking at. We're not looking at everyone anymore. We're only looking out of whatever comes after that bar. So whenever something is given, whether it uses the word given or it just says it in words, you have to change this denominator to be equal to that.